I've been lost in my head for weeks, trying to find what it is I need. Too goddamn tired to sleep.
Happy Wednesday, everybody. Welcome to hashtag chill code. That's what I'm calling this stream now on Wednesdays. We're going to be doing some programming here. And I'm excited because we are going to start something kind of new. Today, we're going to be starting a new programming language. I have not done any work in this language at all ever before. So from scratch, and if you're trying to learn this one too, or really any other language, I think this will be useful because this is obviously not my first programming language. Once that's done, once you learn the first one, you kind of apply some of the same techniques to learning new ones. And so this might be useful to see how somebody might get going learning a new programming language. So what are we going to be doing? I'm going to be going through F sharp. I'm amped about this. I've been wanting to learn F sharp for a while. Here's why, and we'll go through it. But so F sharp is kind of a weird hybrid in that it's open source completely, but it is also a first-class citizen in the .NET environment. So you can write Microsoft .NET applications with it, right? And just like C sharp. So that's pretty exciting. And it's a functional programming language, meaning that some of the same approaches that we might use in Haskell or in Clojure or in the functional style of Rust, we might also apply here in F sharp. So I'm really excited. And so we're going to go through getting a system set up to work with F sharp both, and we're going to do it dual environment. We're going to do it in Windows and in Linux at the same time, so you can kind of see what the differences would be. So let's get some chiller tunes on and get to work. All right. So we're going to start over here in the fsharp.org site, just so we can get an introduction to what we're working with here. F sharp is a mature, open source, cross-platform functional first programming language. It empowers users and organizations to tackle blah, 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 blah. It's a programming language. That's what it does. So right off the bat, it tells you how to get started on Mac, Linux, Windows, or the browser. That's neat. Or what you want to do with it. Now, I'm excited with the Jupyter notebooks as well. There's an F sharp kernel for Jupyter. So that could be pretty cool. But we're going to start with the Linux and Windows side. And so if I click on Linux, it'll give you some instructions on how to get started. The first thing you're going to want to do is download the .NET Core Software Development Kit, the SDK. And as you can see, there's downloads here for Linux. I have it set up on my WSL instance here. You can see I've got F sharp rolling. And you can even see that it kind of tells you how to do this from Linux. So let's actually try this. So I'm going to use Vim on Linux, and then I'm going to use VS Code on the Windows side. Now for Vim, what did I do? I actually went and looked for some syntax bindings for F sharp in Vim Awesome, and I've set that up in my Vim my Vim plugin manager. That is not really, we're not going to spend any time really talking about how to set Vim up the way that I like, but just know that there are plugins available. So I'm going to start this here on the Linux side and see how this goes. So let's vim hello.fsx, and let's see if the syntax highlighting does what I expect it to. Print fn. Okay, not so much yet. Hello world from F#. That's disappointing. I don't know if it actually installed. Let me see if I have it. There is the plugin. I don't know if it actually ran though. If not, see if there's a updated 10 years ago. Okay, well, that's no good. Oh, Ionide. Updated. Here we go. This is what we want. That's what we want. All right, so I'm gonna delete this one, put that one in there, and then we'll run plug update. There we go. Now we got Vim F# going. And we'll close out of that. And dang. Still no do I need Ionide? I have that. Oh, this is for NeoVim. Alright, well, we'll leave it alone for now. Disappointing, but it is what it is. Yeah, we're not going to get 6-year-old extensions for this. Huh. Okay, well, the good news is I can use VS Code either way. Because I've got the WSL extension for it. So anyway, to get this going, it says we want to run, I'll close this out, .NET, which obviously completes, and if I run help, you'll see FSI, start F# interactive, or execute F# scripts. So if I do .NET FSI, hello.nsx, so I get this whole intro because I never ran it before, but then I get the output of the script. So, you know, here's something that's kind of cool about F#. It's functional, but it's not like, it's not fussy. With Haskell, right, you would have to wrap any input-output in a monad and do like all this other crazy stuff just to get a hello world going, right? But with F#, you can kind of just get to business. And that's also really appealing to me rather than doing it in C#. Because with C#, I still have all like the program main, or the, you know, class program, all that other like structural stuff that you get with an object-oriented programming language. I don't want to do that, but at the end of the day, I get code that works the same way as a C# code, which I'm also excited from an offensive standpoint about, because I think that I can write cradles for scary stuff in F# and do some EDR evasion. So you can see that to create a new project, it's a .NET new console, if it's a console application, and then I give it the language F#, .NET run. So that's kind of how it works from the Linux side. Now let's talk about how we would do it from the Windows side. So real similar. And in fact, if I pop over to my PowerShell over here, if I run .NET FSI hello.fsx, it should pretty much do the same thing, right? And let me open VS Code here and see if this thing recognizes it as F#. Okay, it does. Wow, that is very, very subtle coloring. I don't know if I love that. Let's see if we can do better on the color theme. Dracula? Yeah, that's better. That's much better. I like that. That's how we're going to do that. Okay. And also, you know, from VS Code, you can see here, if I just hit play, I'm going to get the output down here. Because VS Code knows what it's doing, especially when it comes to .NET applications, right? So pretty nice. Now, if this is going to be the way this goes, and I suspect it will be for the moment, I'm going to stay in VS Code, all right? And kind of get our documentation up and use that as well. But let's see. So this is how we kind of get started. As you can see, it doesn't take much to get up and running with the language. Frankly, I mean, the .NET Core SDK you need to install. But other than that, it's about as fast as it would be to get started with Python, and a million times more faster. Good job, Taggart. It's a million times faster than getting started with C++ or even JavaScript, to be honest with you, right? All the tooling that you have to install now to do anything in JavaScript. So pretty cool. Now, this is just the getting started. What about learning this thing? Now, you can see that I'm kind of dual worlding this here. That's not a phrase, but I'm going to use it. And the reason I'm dual worlding this is that there's the open source side of F#, and then there's the like .NET Microsoft side of F#, and I want to explore both. So I have the F# foundation stuff here, and then I want to also see what Microsoft has. So I'm starting there. I also should mention I do have the No Starch F# book. I haven't tucked into it yet. Or do I not? What book do I have? I know I have an F# book. Maybe it's not from No Starch Press, No Starch, but so if we need it, I can rely on that documentation as well. Now I'm curious though. I know I have this thing. Let's see, books. The Book of F#. It is so a No Starch Press book. I don't know why it wasn't coming up. But it is absolutely... Yeah, let me open this up. Just in case we need it. I guess I'll open up in Brave. Downloads. The Book of F#. Yeah, see? That's a no starch cover if ever I've seen one. So if we need it, we have this. But I would also, if you're interested in F#, I highly recommend just getting this book. Okay. So, I closed the Microsoft documentation. Let's go to Learn and go to About F#. So things to know about F#. It is strongly typed, meaning that we're going to have to think about data types from the jump. That's good news for me. I think that's important. Functional first, but not purely functional programming language. I think that's really an important difference. Right? Functional first means everything's going to be expressed functionally, but it also means that it has some ability to like handle side effects, right? Side effects, when we talk about functional programming, in a pure functional programming language, every part of the process has to be directly chainable, right? And so the output of one function goes into another function, and that's like the entire run of a functional program, right? There's no other stuff going on that isn't represented in the functional flow. Those other things that might be represented in outside of functional flow would be called side effects. Even things like printing output rather than sending output onto another function, those would be considered side effects. Now, pure functional languages like Haskell have mechanisms to manage side effects, and generally we call them monads, where we kind of wrap the input-output operations in a functional result, and then we deal with them that way. And you can even see that pattern in Rust as well, if you've seen how much like unwrapping we do for options and results in Rust. So same kind of concept, but that's not the case in F#. We can do like the normal business of programming, but with a functional approach. So it's kind of chocolate peanut butter there. All right, so it says learning F#. Okay, well, it's linking us to exorcism, and for sure we're going to do that, but I would really love to have like basic stuff. I guess let's look at the documentation. There's the language reference. Oh, and I guess we're back at Microsoft, so I guess that's where we're going to go next. Yeah. Let's go. Tour of F#. So, the most fun, and it seems like we might be using that book, which is fine. Let me get that open. Thanks, Dave's. Yeah, we might use this as a reference here. But we're not going to read the whole thing, because that wouldn't be a great stream. So, let's get started here with the tour of F#. The most fundamental pieces of any F# program are functions organized into modules. So already we can get some sense of what namespacing is going to be like here. Functions perform work on inputs and produce outputs. Okay? If you've worked with anything programming-wise before, you know about functions, right? We've got inputs coming in and they produce an output. That's what we're doing. And they are organized under modules, which are the primary way you group things in F#. They are defined using the let binding, which give the function a name and define its arguments. So functions are defined with let. And if that's confusing from another point of view with variables, remember that functions and variables are sort of the same thing in this case because they both represent values, right? Now, functions have to operate, to compute, to produce those values, but they, at the end of the day, are value representations nonetheless. So when we think about, function versus variable using the keyword let, don't get too hung up on it. But yeah, we're going to use let to define functions. And you can see the syntax here, where it's like let sample function 1, and then the argument that it takes, the arguments it takes, right, equals x times x plus 3. And then notice that for the variable assignation, right, it's essentially the same thing, right? Whatever this value ends up being, well, it's going to be the result of calling the sample function with this argument. Also notice no parentheses, right? Because functions are kind of first class, the syntax is very simple for invoking functions. This line uses %d to print the result as an integer. This is type safe. Good news. If result 1 were not of type int, then the line would fail to compile. So we have print fn. So this is a print format line, right? So we get the format of %d, and then there's your syntax for embedding the value in the string. When needed, we can annotate the type of a parameter name using argument type. Parentheses are required for this. So this is where the typing really comes into play. So let's say we have sample function 2, and we want to define specifically that x is an integer. We put the parameter typing in parentheses, and then we do the function implementation on the right side of the equal sign. Okay. Here's our conditional. So if, then, you don't always see an explicit then, but I don't hate it. I kind of like having it there. And so this is control flow for the function execution, right? So sample function 3 takes the argument x, and notice that it's just like if x is less than 100, it's going to return this result. Otherwise, it's going to return this result. Okay. So, and as you can see, let is also how you just assign values to variables. So let kind of does double duty because, again, values and functions in a functional language like this are at a certain layer of abstraction indistinguishable. But it is good to note, oh, this is cool. That if we want the value to change, we have to use the mutable. So you can see a lot of patterns from things like Rust as well in here. Although Rust actually was inspired by ML. And maybe a little F#, who knows? I guess the inventors of Rust do, but I don't. Numbers, booleans, and strings. So we've already covered, you know, when we talk about the 4 fundamental structures of programming, variables, conditionals, loops, and functions, right? Well, we've got variables and functions knocked out at the same time here with the let expression. We've got conditionals, and we haven't talked about loops yet, but I'm sure we will get there soon. And then for data types, it's telling us that F# supports the same underlying primitive types that exist in .NET. So here's how various numeric types are represented in F#. We've got integers, floats, doubles, and you could do ranges here, right? 0 to 99. That's really handy. This is a list comprehension, very similar to what we would do in Python, except that we've got kind of a forward-looking lambda expression here. That's kind of cool. Booleans are lowercase. Oh, that's funky that the Boolean operators are not without instead of an exclamation point, so it's not a bang. Double ampersand and double pipe for and or. Those are pretty common. String manipulation. So strings use double quotes. That's going to be important. Strings, I would assume cars are single quote then, right? Individual character representations. Which probably become like byte arrays if you do a bunch of them. String concatenation works. Oh, if we need to escape characters, we can do verbatim, right? Like this. It's neat. Tuples. Tuples are a big deal in F#. Grouping of unnamed but ordered values that can be treated as values themselves. Think of them as values which are aggregated from other values. They have many uses, such as conveniently returning multiple values. Yeah. From a function or grouping values for some ad hoc convenience. Got it. F# type inference will automatically generalize the function to have a generic type, meaning that we'll work with any type. That's kind of cool. So if I don't define types like this, and I'm not doing any like weird, like math specific operations with it, it's going to generalize it up to as I guess as general as it can make it. Interesting. struct tuples. Pipelines and composition. This is where the functional stuff really starts to kick off here. Pipe operators such as pipe greater than are used extensively when processing data. So what this does is like take the result of a single expression and then you send it off into the next function. So here we're creating a bunch of different functions here. Square, add one, is odd. Oh, notice the not equals syntax, right? Numbers. And we're going to learn more about lists later. And then we're going to square odd values and add one. It says let odds is list.filter, which that's how we do namespacing, is odd values. So we're basically filtering the list of values, whatever that is, for anything that's odd. Then we square each of them with map. This is some of how we do iterative stuff. And then we just return the result. This is clunky, right? You don't want to have to do this. And you don't have to, right? So what we're looking at here, these three examples are three ways of validly expressing the same thing, but there's like better and worse ways of representing it. So here, right, we're using a lot of stored values to get the results at the end. Here, we're doing function composition, and we're doing it with parentheses. So this is totally valid, but the problem is that it's super hard to read, right? And this is one of the big dings against things like Lisp and Scheme, which is that, the parentheses can be a little bit difficult to deal with. So instead, we are going to do this, which is this pipeline, where we send values off to listFilter.isOdd, and basically, see how up here the second argument was values? When we do a pipe, it like infers that this is going to be the next argument in the function. So then we take whatever that is and we map that, we send that result off into this expression, right? So we're going to square the result of this and we send that over into this. And that all together is going to be what we return from this expression. And then one last way to do it is using the lambda function. We haven't talked about lambdas, but they're kind of in-place functions that you write when you need a quick function and you don't want to have to do a let statement, which we do with fun here. So we're mapping see how, okay, so basically what we're doing with this this lambda function is we're combining the operations of square and add one into a single statement here. So for everything we get from the isOdd filter, we're sending over into this lambda, right? And so what we do is for every one of those, we pipe it into square and we pipe it into add one. And because we do that for each of the things from isOdd with map, we get the same result. Of these, I would prefer this for readability. These other two introduce syntactical complexity that is not necessary. And I don't think it saves you that much. So whenever possible, when we have a chain of things that we need to do, this is, I think, the best way to do it. All right. Collections, lists, arrays, and sequences. Lists are ordered, immutable collections of elements of the same type. They are singly linked lists, which means they are meant for enumeration. Okay, so important distinction from Python. Lists here are ordered and immutable. lists in Python are not immutable, but when you have both lists and arrays, it's common that that's the case. So a list is immutable. Notice that we've got semicolons separating them when we create them. We can create a list with a range like this. Notice that we're pulling in, this is like, we haven't talked about it yet, but see this right here? What's super cool about F# is that we actually have first class access to the .NET framework, right? So we get all the cool stuff that we would have in C#, but we have it in a functional language, like so system.datetime, days and month, all the stuff that we would do, or stuff that we would do in PowerShell, right? So we have it here in F#, so I'm excited about the potential for that. Print the first 5 elements of days list using list.take. So we've got, this is list.take is a lazy expression, or lazy evaluation rather. We'll talk about that later. Computations can include conditionals. Oh, notice that we're doing a for loop here without talking about them yet, but look. So we've got for do, it's a nested loop here, and then yield. Interesting. Okay. So one of the things we're going to want is to understand the list namespace and everything that we can do with it. But we'll stay over here for now in the tour. Now arrays are fixed size, but they're mutable. And so the array syntax, I've never seen that before, where we have the square brackets and then we have pipes to delineate the array. That's really interesting. Yeah. So arrays, what can we do with arrays? I want to know, where's my... Oh, wild. I got taken someplace else. So for the real language reference, we're going to be over here in the F# foundation. Is that the language spec? No. The language... No. What the... Oh, here we go. The core .library documentation. So if I go to like collections, there it is. So there's array, and this is where we learn how to do cool stuff with arrays. Yeah. So does array also have filter? It does. And map, one presumes? It does. Nifty. Okay. You can modify the constants of an array element by using the left arrow assignment operator. Good to know. How do I append things to an array? There's our for loop again. So array of .append builds a new array that contains the elements of the first array followed by the elements of the second. So that takes two arrays and combines them. So concat, is there like a push maybe? No. Sequences. So maybe the way that we do this was like, just this is how we do the assignment. Sequences are a logical series of elements, all the same type. These are more general types than listed arrays. They also stand out because they can be lazy. Okay. Recursive functions. Processing collections or sequences of elements is typically done with recursion in F#. That's an important sentence. Processing collections or sequences of elements is typically done with recursion, meaning that we prefer recursion to looping. Okay? That's really, really important. Okay, so let's see. If n equals 1, n equals 0, then 1, else n times factorial. So this is a factorial recursive function. GCF, sum list, Q. Okay, so far we haven't done any coding, and that's got to stop. We have to write some code before we get out of here. So what I'd like to do is actually write a really, really simple example script, and I'm gonna call it ispal.fsx, and I'll call it module ispal. Am I doing this right? Oh, I gotta have an equal sign. Yeah. Okay. Cool. So. We're gonna write let ispal equals, and ispal, we'll call it s. Look at this. Look at how the syntax highlighting is going. I'm getting kind of type here, and let's look at the primitive types because I want to make sure that I'm describing them correctly. Okay, it's called a string. So remember, this is my first time ever doing look at that typing that it's doing for me. That's really, really freaking cool. Wow. Oh, I have to indent this because it's inside the module. It's white space sensitive. Yeah. Okay, I'm already really into this language. Okay, but what we're trying to do is see if something is a palindrome. Now, let's see. What can we do with strings? Right, obviously we would need, like, the length. So, let's say if s dot length, yeah, that works. Let's go back down to our recursive functions. Oh, it still equals 0. It's still a single equal sign. That's gonna take some getting used to. False, else, true. And then we're gonna do print fn we'll say, call it let res equals ispal test. Res. Okay. What did I do wrong here? I forgot the then. Now what are we getting yelled at for? Oh, that's... Man, iodide. Freaking rules. Replace with not s.length equals 0. Right, of course. I'm going to leave that as is for its explicit nature, but it's cool to note that it gives us that quick fix. All right, let's run this. Nothing happened. Why is that true? Oh, hey, I just had to save the code. You know, no big deal. Okay, cool. So we have this structure kind of working. Now, for a palindrome test, this is kind of neat. If s length equals 0, then false. Is there an else if? Yes. S dot length equals 1, then true. Else. Ah, that looks good. So here's the part that is interesting. So what we're doing with a palindrome test, let me just comment out a line here so we can test it out. So with palindromes, like here's a palindrome, race car. So the simplest palindrome, right, is a single character. We know that that's always a palindrome. So that's why we said length equals 1, then true. But if it's not, then let's say it's 2. We want to see if the beginning is the same as the end. So see if our core documentation let's go with strings. Is there like a head or tail? No. That'd be asking too much. But it implements system.string stuff, so which I already have open. So are strings indexed? Gets the car object at a specified position in the current string. We got some splits. Let's just see .NET string indexing. No. Okay, so that works. What it'll give us is the car rather than, but that's fine. So what I'm trying to do is, if I want to compare the beginning to the end, I have to compare that index 0 is the same as index length minus 1. So to do that, we would say S0 equals S dot length minus 1. That gives us the last. And is pal. This part is where we get a little bit funny. S dot split, or substring, actually, I think is what I want. Yeah, it is. It's dot substring. Now with substring, what do we need? Substring takes the substring starts at a specified character position, which would be index 1, and has a specified length, which would be S dot length minus 2. Let me full screen this here. Now, what's the problem here? Make outer binding recursive. What just happened? Oh, use ispal.ispal. Right. Now it's still yelling at me about S. Successive arguments should be separated by spaces or tupled, and arguments involving function or method applications should be parenthesized. So does that mean I shouldn't do this? It should be like this. The value namespace or module ispal is not defined. Yeah, it is. But just in case. And then the value is not a function that cannot be applied. All right, so we're getting somewhere. Let's look at that cars note. Yeah, that works. Yeah, that should be working. Let's see how this goes, if it does anything at all. Okay, so S is a problem here. Is it two equal signs? This value is not a function and cannot be applied. I don't know what that means. This typically occurs when passing too many arguments to a function. It can also occur when you do operator overloading. Okay. Then I think we need to learn a little bit more about basic comparisons in F#. Language basic operators. Okay, structural inequality. Let's look for equality. Okay, it is an equal sign. It still doesn't want me to deal with S. Okay. I feel like maybe there's something I need to do with strings that's different in okay, well, for... Oh, wild. Okay, so it's... Here's the deal. So it's string.length. String.length s minus 1. Yeah? Ooh, wait. Okay, so built a new string. No. So this is all the stuff I can do with strings, but that's actually not what I want. I want s dot Interesting. Okay, so if I do s dot substring 0, 1, equals, I'm gonna clean this up a little bit. So let head equal s dot substring 0, 1. Let foot equal s dot substring s dot length minus 2, 1. String dot. That's so funny that it doesn't let me do access the property of the thing, but I can grab it with the string dot length. That's interesting. So basically, I'm pulling the head off and the tail off, and I'm saying head equals foot, and okay, but we've got his pal here. Oh, insane. Is pal dot, is that right? No. That didn't work. Is that because I can't overload? I can't name a module and the function the same thing? Call it check pal. This is how we learn. When you use F# Interactive, you first need to evaluate the code that defines the functions that you want to use. So if you just select the last line of your script, you get an error, I suppose. It's not really. the obvious case for something. Okay, so interfaces. Okay, so its recursion is our problem. The reason is that when the compiler sees fib in the body, it doesn't know about the function because it hasn't finished compiling it yet. The fix is to use the rec keyword. Oh, so if we call it a recursive function, does it know that we're good? No, what the hell's the problem? Okay. I think we got it. Dope. Okay. So now, now we can do, let's try it against race car. Should probably save it before I run it, huh? What? False. But it's supposed to print this every time it goes through, which it's not doing. Except maybe it's because let's print fn head. All right, let's see what we're getting wrong. I'm sure it's an indexing mistake. Yeah. There we go. So we can comment these out just to get rid of them. So now we have a palindrome checker. This is cool. So, and it's done recursively the way that we would want it to be, right? So now you can see it kind of go where it's doing race car, ace car, CEC, and then the reason why, actually this print should be right up top because we don't, otherwise we won't see the final stage. There we go. You see how it's taking the beginning and the end off each of those. And then we get true. Cool. I am not hating this language, I gotta say. There's a lot that's promising here. All right. This, by the way, F# for fun and profit. Let's bookmark this. Actually, yeah. All these errors have amazing troubleshooting. This is incredible. It's a really good resource. Yeah. we were at recursive functions. Oh, I should have read the rec. It was right there, and I didn't see it. But that's, you know, that's how that goes, right? I won't forget it now. Union types and records. So this is important. This is like key value pairs, right? This is how we produce something like a dictionary in Python. So this is, I see. So this is a record type. This is almost like a struct in Rust, or, you know, where we define the types for each of the values, and then to assign them, we can do it like this. Yeah, looks just like a hash table in PowerShell. Yeah. Oh, and then you can do kind of inference here. That's pretty cool. Copy and update. I like that. Remember this printed contact card. Oh, cool. So what we're doing here with a member is we're adding essentially a property or a method. It's a method. It's only methods because there's only functions. That's cool. I like that. You can use decorators to do it too. Nifty. Now here's how we do union types. Okay. So of is the keyword for union types containing value. All right. And then we have pattern matching. Match imp with. Okay, so we have guard. These would be called guards in Haskell. So this would be another way we could rewrite our palindrome function with pattern matching. So to do that, we would do like, let's see if I can figure this out. Match s dot. Oh, insane. So weird. Math s.length. So if I do match s.length with, and then I do 0, false, right? 1 would be true, and then the default would be this stuff, which I'm gonna uncomment. Can I do it this way? Yeah. You just have to make sure that the white space works. So let head, let foot, head equals foot. Let's run this and just make sure it still performs the way we'd expect. Ah, nice. So you can see how we kind of cleaned up the if-else chain with these guards, this pattern matching. Ah, that's nice. And you want to, I don't know, this is nice clean code. I would do this whenever possible. Certainly more than the if-else chain. That's neat. Also notice that we open the modules from .NET, the namespaces from .NET with open rather than using or anything like that in C#. One unique feature of F#. I keep seeing this units of measure. We'll get out of here in a minute, but this is kind of neat. I saw that units of measure is something that F# prides itself on, so let's see what it's talking about. Allow you to associate a numeric type to a unit, such as meters, and have functions perform work on units rather than numeric literals. That's pretty cool. So it has a whole library. Oh, and look, you can create this type mile, meter, 16.0934 divide meters to miles. Meters per mile. Oh, that's really neat. That's really neat. So, does that mean that I have Microsoft.fsharpdata.unitsystems. I want to see the ones that they have. I mean, if this is like a pretty reasonable way to do time measurements, that's pretty neat. All right. Classes and inference. So you can do .NET classes, right? And oh, sorry, not inference, interfaces. So you do types, member. This is how we do methods. Okay. And an interface is kind of like a trait in Rust. It's a contract saying that this type is going to implement these specific things in order for you to work with it a certain way. Okay. Now there's an introduction to functional programming here. But we now have a pretty, we've reviewed the language in a pretty, cursory way, but we've gone through quite a bit. We've written some code. So I think the next thing that we're going to do, and we'll do this next Wednesday, is we're going to do some exercism exercises in F# and see how we do. Cool. All right. Well, that's going to do it for this stream. Hope you enjoyed chill coding. I know I did. And I will see you on Saturday for Saturday Hacker Day, where we do some defensive cybersecurity stuff. Until then, I'll catch you next time. Happy hacking, everybody.